Hi, yes, I'm back in the garage, and yes, we have another portable battery station today. We're going to do a teardown and quick review of this thing. Thank you very much, AllPowers, for sending this one into the mailbag. This is the R1500. Don't know why they call it the 1500 because it's an 1150 watt hour capacity battery, 1800 watts maximum power output on this thing. And of course it's a lithium ion phosphate chemistry battery with over 3000 charge cycles, so they claim. Obviously can't test that. And it's got 4 240 volt Aussie plugs on it, none of that 110 Yankee rubbish. It's got 2 USB-Cs, 2 regular quick charge USBs. It's got DC cigarette lighter output, and it's got 2 30 watt wireless charging pads for your shoe phones on the top here. So yeah, let's check it out. Weighs about 16.7 kilos, which isn't too shabby for the capacity. Street price is 999 Aussie bucks. Obviously that's going to be substantially cheaper in American bucks because you're not paying the Australia tax. So show you around up close on the outside of this thing, and then you know what we say here on the EV blog, don't turn it on, take it apart. There's the front of it. So it's got 4, there you go, Aussie plugs on it, and 100 watt USB-Cs, 2 of those, and 18 watt USB-As, and it's got the Bluetooth and the Wi-Fi's as well, but we don't care about that sort of rubbish, and cigarette lighter plug, and we've got one of those wanky screens on it. We'll check that out later. And before I started even using this thing, I got it delivered to the lab, and I switched it on just to make sure it worked, and then what I forgot to do, is that I forgot to actually switch the outputs off before I actually put it back in the box. And the problem with that is when you put something that's powered up, and even though there's no load on it, of course, it's going to dissipate some power, and then it's surrounded by these foam padded inserts. The next day when I brought it home, the box was warm. Yeah, because the heat couldn't get out of the thing. So yeah, don't do that. So yeah, it'd be nice if they could actually like have an auto time off feature for this thing. Anyway, claim your warranty. There you go. What do we get? Visit us on Facebook. There you go. Portable power station version 3. Thank you very much. It's in all the requisite languages. There you go. There's the Aussie stuff. You don't get any of the extra cables with it. You just get the mains plug, and that's it. Although you can buy like combo packages with the portable solar panels and stuff like that. We do get a nice little carry case for the leads though. Then on the top here, you can see the 2 15 watt wireless charging pads. That's really handy. On the side here, we've got this groovy looking vent, and then that, and there's your connections for your external batteries. Yeah, custom connected jobby. Nothing doing on the back except the specs. Other end, we've got more funky air vents here, and inside we've got our mains input here, we've got a resettable fuse, and we've got just a standard DC input connector here for your solar panels. So all my existing solar panels and leads I've got for other batteries, they all connect. Whoa. That didn't sound good. You can sit on it, Potsy, but I think I just cracked something. Yeah, it's not the most robust thing. So, yeah, I don't know if you heard that crack or not, but that was a crack when I sat on that. I hope I didn't bugger the wireless shoe phone charger on top, but anyway. I'll do the stand test, see if it can hold my weight. I'm about 74 kilo or thereabouts. On the bottom, we've got 4 rubber baby buggy bumpers that seem pretty decent. So, yeah, it's not too bad, but it's not the most robust thing. Like that EcoFlow battery we saw before, I would deem that to be more robust than this one, although that cost like 3 times the price or something, and was much bigger with the carry handle and the wheels and everything. Anyway, AllPowers do make bigger ones than this. This is like just their sort of like mid-range unit. Anyway, I do like how the handles are nice, big, beefy, and they're undercut in there too, so your fingers aren't going to slip out when you're carrying this thing around. So that's a really good design element. I really like that. All right, it's teardown time. How this is going to work is there's some really long rubber plugs which go into here, which is nice. It looks like there's a split down the middle, so it's not going to lift up. It's going to look like this rear panel is going to lift off, so I have to like flip it over and that will lift off, I think. Well, I don't like that these screws are self-tappers. What? Why? Ugh. So yeah, it looks like this rear panel comes off like that, but yeah, self-tappers. into the plastic. Not happy with that, so yeah, you have to get this off, otherwise this split rear part is not going to come off. Looks like we've got two piddly little fans in there. I would have liked to have seen one larger one to get, you know, just minimise the noise, but I can't remember what the noise of this thing's like. Well, actually, I haven't put a full load on it yet, so I don't know. And you can see the main PCB right through there. I'm not sure if you can see, but you can go right through. So the airflow on this thing, like, I really like it. Out in one side and out the other. It's well designed. And I think there's a reason it creaked when I sat on it, is because this looks like a clippity doodah top panel. That's a bummer. Yeah, so I wouldn't go sitting on your battery bank, which is a shame because it's like nice height, nice bum size, and ta-da! There you go. There's our little wireless pads. Neat. That's nice. Yeah, I like that. So there you go. There's our wireless PCB. That looks pretty decent hardware on there, actually. Liking that. Well, it is a 15-watt jobby. I think there's a couple of clips on the top I need to snap out. Really not seeing how this top is held in there at all. Really? Oh, I've got to peel off the sticky rubber hand grippy things. Oh, that's bad design. I don't like that at all. Take one for the team. What they could have done is just had a split in that. So I think I'm just going to get my knife in there and just cut that straight down. Like, it's just dumb to put one big piece on there. Give me two. All right, so after I slice and diced that, it's still got a sticky bit there. And ta-da, we're in. Ooh, that looks nice. All the BMS is all exposed. Excellent. So there's our BMS. We've got our two battery terminals here. Very nicely heat shrunk and crimped and everything else. I like the sleeving on here. It's all cable tied. It's all looking very neat and professional. I'm very impressed. So yeah, nowhere do I see that the wires can get snagged or cut on the metal or anything. So that's really groovy. So anyway, let's measure our battery here. So 2 negatives here and 2 positives up there. Let's probe that sucker, and 0.35 because, well, it's not switched on. Maybe if I switched it on, might actually get some. Okay, it's now on. You can see our LED flishy flashing, and yep, sure enough, 48.26. It's only at 9% charge. So yeah, so hopefully you can see some more detail in there. Sorry, I'm not going to comprehensively get part numbers and everything else, but maybe you can make that out. I can't see it on my camcorder screen here. Okay, I'm very impressed that they've Celastic down the connectors here, so vibration isn't going to be a problem there. They got the shake-proof washers on there. Looks like we've got a big 100 amp 75 volt fuse up there. That's like big ceramic package. That looks really nice. But anyway, quite liking the BMS down here. And is that a current shunt array there? Another bunch of current shunt resistors down here. I like how they've added the surface mount little shorting links on there for just increasing the current carrying capacity on the PCB. And they've done that up the top too. They've soldered them there, not on the ones up the top here though, but that just allows you, because there's only certain copper width in there, just allows you to have greater current carrying capacity right across here like this, with a given width and a given copper weight on your PCB there. There's a couple of unpopulated parts over there. They look like diodes maybe, they're not populated. So we're obviously doing all our cell balancing in here. That looks pretty neat. So I'm rather liking this. So this looks very well designed. I can't really fault this. Pretty impressed. Now, unfortunately, to get into the inverter side here, all of the insulation here is tied into all of the screws in here. So I'd have to like take all this assembly out, or I'd have to cut through the insulation here. I guess I could do that and then tape it back. That's better than trying to, yeah, I might have to do that. It's better than trying to like undo the screws, which are all down on the board, actually behind there. So So I can actually get the front panel out, but it's all connected through to the cables, so it's a little bit annoying. I'd have to break all the Celastic seal on there to get it out. But anyway, I'm really liking what I see down in there. You can see all the MOSFET switches down there for the outputs. They've gone for those surface mount bus bar things again. I'm liking the insulation and the crimps there on the big cigarette lighter jack. And not sure what processor that is. Can we get a torch in there? Can you read that? Can't read it on my camcorder screen. But nice attention to detail down in there. They got Celastic on those caps just so that they don't vibrate on the board. When you whack this thing in the back of the car, you're driving down the dirt road to the Outback Dunny. You don't want your capacitors and your inductors to come loose. But anyway, that's looking quite neat. And then down the bottom there, that's our mains board down there. So they're all in parallel, of course, but that's all looking very good. The earth connection is just directly soldered on the board there. I would have preferred like a crimp and a screw or something, but anyway, it's hard to nitpick this design, really. It's implemented quite well. And this is all really nice quality rubber sleeving on here too. I really like this. So this prevents all the cables getting snagged on any, burrs on the metalwork or anything. I'm not spotting anything dodgy in here at all. It's great, especially for the price point. And there you have it. We have inside this thing now, we have a bit better light going on here. So I'll just show you that BMS again, because it's all about the light coming through. So there you go, there's the BMS. And here is the top side inverter. Right off the bat, we've got a Shy branded caps. They're one of the bigger Chinese ones, so that's exactly what you'd expect. The 550 volt 220 mic jobbies, there you go. Is that a Shy? Now this is interesting. They got a sticker label here that will turn red when it gets wet. No warranty if product or water gets in. Yeah, of course. Yeah, maybe that's been a thing for them, because people use these things outdoors and they return the thing busted. Oh no, water got in. No, not at all. Anyway, there you go. There's the MOSFETs down in there. They're NCE MOSFETs, are they? Hopefully you can see those. But yeah, I'm liking the look of this. Liking the look of all the coils and the transformers. Got some big ass relays there. What brand are they? HF161F there. That's basically what you'd expect. Never heard of that model fan. It's like whatever. I still haven't powered this thing up under load, so I don't know. They've got a little SI controller. It's got a little daughter board in there. Not sure what that does. Yeah, I'm liking this though. And you'll notice that all of the, look, inductors, they're all gooped down. Very, not like hard epoxied down. So those things aren't going to vibrate at all. That's really quite nice. So yeah, very happy with the look of the inverter in here. Massive bus bar going across here and around here as well, because there's only so much you can do on your PCB, and you don't want to pay extra for your 5-ounce copper or whatever. The vertical fuse there, nicely heat shrunk. Everything's really neat and tidy. They've taken quite a bit of pride in the design and construction of this thing. There's your main battery leads there. They're just going through it like into little ferrules and then soldered into the crimp ferrules and then soldered into the PCB by the looks of it. That's looking great. I'm very happy with this. So yeah, Teardown, thumbs up. Can't really fault it. Leave it in the comments down below if you spotted something that I can't see with my Mark I eyeball and my crappy little camcorder screen here. But yeah, very, very happy. Wow, especially for the price point. It's just great. And you'll notice the main heatsink has a little temp sensor on it too. Nice. Guess the only thing I'm not that happy with is just the way they've constructed the case with this split in it. It's not very robust, and the self-tapper screws into the plastic for the outer panels. Would have liked to have seen that. But apart from that, the bolts actually holding them in are quite decent. But yeah, just the way the split plastic housing, I don't know, I would have preferred like the whole thing lifted off and it was just one big, solid molded piece perhaps. Okay, managed to get a cable out. We can have a look at the pack here. Sorry, I'm not going to get it apart even further, but it's got LTT on there. offhand, I don't know, is that the manufacturer or something? Anyway, 32700, hopefully you're reading that. 32700, 6000 milliamp hour cells, and date code 2024, 1st of the 7th. So, I don't know, they've got a big plastic array in there, of course, to hold all the individual cells. So sorry, I can't show you the tab welding on those, but anyway, we've got some insulative sheet around the back there, but looks pretty decent. Big earthing up to the metal frame up here by the looks of it. Oh yeah, that's the earth for the front panel down in there. So that's looking quite decent. Don't mind that. I guess LTT is the brand. I'll have to research that. I'll put an overlay if I can find anything. But yeah, that's 6,000 milliamp hour a cell. I don't know. Count them. Not sure how many is in there with the width. They do go right over. It's hard to see in there, but yeah, the cells go right to the edge there. But they are lithium iron phosphate, and I think they rate them for at least 3,000 or 3,500 cycles. Yeah, just putting this back together, I'm not impressed with the way that the plastic is like just really decoupled from the rest of the metalwork. The plastic's like a shell around like the metal frame on the bottom. So yeah, I'm not, it's probably adequate for like in terms of robustness for outdoor use, but I wouldn't be writing home to your mother about it. All right, I've switched it on and I've plugged the mains power in the side, and there you go. It's charging at 600 watts now. I assume it'll get higher than that, glare. And the screen is just very similar to the EcoFlow, almost like it came out of the same factory or something, like they're copying each other. And yeah, it's progressively going up, so it doesn't just instantly ramp up. I can't remember what the actual maximum charge rate is. There's no button on it to actually, I'd like to see a button on the side like it had on the EcoFlow one that allowed you to choose fast charge or like a programmable slow charge. So I'm going to have to get the Shoe Phone app out and try and connect to this thing and figure out if I can adjust that charge rate or not. Anyway, in terms of fan noise, you probably can't hear it. Yeah, well, I can put up the... There it is there. It's quite low. It's much lower than that big EcoFlow one I had, but that's, I guess, to be expected. So yeah, sorry, can't get a noise meter on that outside like this. But anyway, yeah, I deem that to be relatively quiet at almost 1,000 watts charge there. So quite happy with that, actually. So it did jump briefly over 1,000 watts there, but it seems to be hovering around 950 to just a smidge over 1,000, something like that. So that seems to be the max charge rate, at least at 12%. It's going to, of course, it might modify the charge rate and hence the power taken based on what the battery percentage is. So, all right, let's plug a heater into this thing. This is a 1,500 watt ceramic heater. So the output, mains output here is on. 1,000 watts output, 940, 970, yeah, 1,000 watts. It's supposed to have 1,500 watts max, but at least it's given 1,200 watts, and that's plenty. For a battery of this capacity of this size, that is more than enough power. That's just enough to charge the EV. Just, if you were desperate. Not that you get much range out of 1,100 watt hours capacity, but it might get me out of trouble. That'd give me about 10 kilometers range or something like that. If I was absolutely out of juice in my EV, technically you could slow charge it from this bad boy. And yeah, well, there you go. I've connected the EV up. Does it actually work? No, it just cut off E2. It started working for a minute, of course. It's trying to take the 2,200 watts. Like, the car is capable of trickle charging at, I think 800 watts is the absolute minimum, but the actual Hyundai charger here is not capable of programming to that lower level, though, unfortunately. So, in theory, it's possible if you got a charger that supports a deliberately low, that's telling the car, I want to charge at like 1 kilowatt, something like that. All right, so I had it at 100% and I just switched on the fan, so we're getting 1.1 kilowatts there, and it's pretty spot on here. As you can see, 227 volts out, which is because we're 230 volts here in Australia, not 240 anymore. And we're going to run this heater and we'll get and accumulated total. So we're expecting, you know, around about 1150 watt hours. So we'll see what happens. But there you go. We're down 97% already, but we'll give it a go. E2, now it was giving me E2 the other day because that was like an overload on the input. So maybe there was like a little surge there or something. I don't know if that error will clear itself or not, but because normally it says time remaining there. So I'm not sure what the... Oh, yeah, there we go. Yeah, I actually just cleared that, so I didn't switch it off. Yeah, there you go, 51 minutes remaining. So we'll get back to you, see if it meets its rated capacity. So we can just switch the function there to watt hours, and there you go, that will accumulate, and we'll get a time there and a total kilowatt hour. So we'll see if it matches its rated capacity. Unfortunately, I goofed up the recording of the end result there, but I got 900, I did note it, though 924.8 watt hours at the 1100 watt load. And as is quite common with these things, as I said, they're pretty non-linear. It's been at 99%, and it's saying 1 minute recharge for the last like 15 minutes or something. So yeah, it's still pumping it in there. It'll cut off eventually, and then we'll start another discharge test. So yeah, it's significantly under capacity, but that is at a very high load. So I'm going to actually rerun this thing now. I've recharged it to 100%, so I will rerun it now with the heater on a smaller load. So let's turn that on, and it's going to switch on. Come on. It does take a while to switch on the output, by the way, but there you go, 100 and that will get higher. All right, so it looks like it might creep up to, say, 600 watts there. Anyway, it doesn't matter, it all comes out in the wash, but this is a more modest load that you would have on an 1100 watt hour capacity battery. The 1100 watts we had before was pretty extreme. Like, you know, you're only going to get like less than an hour out of the thing anyway. So really, yeah, that's not the sort of load, but it is capable of that load, so we tested it. But anyway, yeah, 588. We're measuring 590 on here, and we've been monitoring the energy for 3 minutes there, and we'll see if it should be, I think, closer to the capacity, because you will be looking at a different part of the efficiency curve of this thing. There will be a peak in the efficiency curve based on the load power. So the efficiency curve will drop off at low loads, and it'll also drop off at the higher loads, but there'll be a fairly big sweet spot in there. So anyway, get back to you. By the way, the fan noise at 600 watts there is really not much. I can hear the other fan more than I can hear this one. So yeah, it is. I really do like the fan in this. It's not silent, but it's pretty low. All right, let's do a sine wave test. I've got my high voltage differential probe plugged in to the mains output here, and I've got my heater switched on, and you can see, yeah, it's not too shabby at all. That's half power. This is the full, what is it, 1.2 kilowatts or something like that. So yeah, sine wave, no problems. Like, there is a little bit of like crossover noise here, but it's neither here nor there really. That's a perfectly acceptable true sine wave output at high power. And I'll turn the load off actually. Well, there we go. So no load. Whoa, full load, you saw a bit of switching there, but that's neither here nor there. And of course, just be aware that this is not an uninterruptible power supply. There you go, I captured with pulse triggering. This is 10 milliseconds per division, and there's a switch over there when you go from battery to main. So just be aware of that, because I've had an issue here, and you've seen in a previous video with my EcoFlow Delta, where this had exactly the same issue, and it meets spec, by the way. It tells you this in the manual that it does have a changeover period. So yeah, there you go. But expect to lose a cycle or something. And I had an old fridge here, which really, the compressor inside did not like that, and the compressor locked up, and yeah, my fridge stopped working with my EcoFlow Delta Pro. So just be aware of that if you're switching over from mains to battery. But obviously, if it continuously runs on battery, then no worries. So there you have it. That's a look at the AllPowers R1500 battery. And well, I've found a few issues with it, and it's not the most rugged thing out there, but it works and it does the job for the price. So I guess you could have to compare it with similar price units. But, you know, it's decent, seems to be decent value for money in terms of the watt-hour capacity that you get, even though we didn't seem to get the fully usable watt-hours based on the mains. I haven't actually done that based on like the DC output, because, of course, you'll get a higher efficiency if you less losses internally in the inverters if you go from the DC battery inside to the DC here rather than step up to the 240 volt AC mains. There's going to be less loss there, but I was with the 240 volts, I was not able to get the full rated capacity out of the thing. So you're either going to find that acceptable or not. I don't know. Once again, you'd have to do a complete shootout with other similar priced models on the market, but it works, and I'm going to use this. This is going to be my outdoor camping battery, and we are going camping soon. So I'm going to take this baby, and it will be powering a freezer fridge thing, and it should do the job. I'll take a small solar panel with it, and I think it's going to work a treat. So thank you very much, AllPowers, for sending that in. It's good enough for Australia, as we say. It's not the highest quality thing out there, but I was impressed with the internal build quality of thing. I just wish they, you know, external build quality could have been a bit better, just the way, you know, everything goes together externally. Could have been a bit more robust, but I don't know, for the price, check it out. Links down below. Catch you next time.